Good evening, Arya. Arya, you studying in which school? From which school are you? And is half yearly exam going on in your school or will be going on, or what's the syllabus regarding biotechnology? Okay, LPS. Okay, so what's the syllabus for your biotech course? Because Samish had sent the syllabus to me as per his syllabus, like the biomolecule, the I, this one intellectual property writing. So all these things have been completed, and we are doing the errors in cell division. So that is the last chapter as per his syllabus in biotechnology. So you can contact me on my personal number, Arya. Rahul Sahab is my name. You will be finding my number there also. You can just send your syllabus to me so that I can know if I have to teach something else. Okay, if any problem arises as such. Okay then. So what we were doing is we were doing something regarding the. Just text me. I'll just text you back. Okay, after the class is over, so that we can have a better tuning. So we had done the knot disjunction, the inversion, right? Or the paracentric pericentric both, which involves the, yeah. Good evening, Pratham. So those things we had done. So today we'll be dealing about the chromosomal mutation. Okay, in cell division there are errors known as chromosomal defects, right? So chromosomal defects are something as that will change the roll number, you can say. Or suppose the chromosomal number of a species. So chromosomal number of humans is how much? In humans, the chromosomal number in case of diploid nature or diploidy is 46, haploidy is 23. So we are all diploid creatures. So if the chromosome number becomes 47, would you like it? Like you may like it, but the thing is, your body won't like it in the sense that you will be having some extra, you can say, copies of proteins because the extra copies of genes will be present. So you'll be having extra proteins produced. That will be causing a lot of side effects, a lot of pathological and therapeutic defects. Okay. Now, these are known as chromosomal defects. In plants, what can happen is the entire set gets duplicated. Suppose a plant is n plus n 2n, so it can be one more set is added 3n, 4n, 5n, like this. Entire set is added up, not a chromosome. Entire set is added in case of plants. Okay, that doesn't happen in case of humans. So what happens is, so one set of chromosome, okay, one set of chromosome, one true set of chromosome is known as euploidy. Ploidy means set. It is true set, you can say. True set of chromosomes. U means true. Okay. So once your set is a true set of chromosome, meaning that what we have here is a 46 chromosomes in case of Homo sapiens. That is a true set. Okay. Whenever we deviate from this true set, what we have is aneuploidy. Then what we have is aneuploidy. An means non-true set, meaning that if we have 47, 48, 49, or even less than 46, 45, 44, like these are not falling into the true set of chromosomes. These are either lesser or you can say more than the number of chromosomes required for that specific species. So they are recognized as more than or less than the euploidy. So they are referred to as aneuploidy. Okay. So there are multiple aneuploidic diseases when it comes to humans. Okay. So the first aneuploidy disease is a sex chromosome disease. So we'll talk about two. We'll talk about allosomic aneuploidy diseases and autosomal, no, autosomic aneuploidic diseases. So allosomal aneuploidic means involving the change in the sex chromosome. Okay. So allosomal aneuploidic diseases, aneuploidy versus we have autosomal aneuploidy. What happens is here what you have is change in the sex chromosome number or allosomes means the last pair, the 23rd pair, XY or XX. So change in sex chromosome slash allosome number. Here change in non-sex chromosome is the first 22 pair, so change in allosome number. The change in the number of allosomes. So these two are the basic, you can say, demarcation entities when it comes to dividing, when it comes to demarcating an allosomal aneuploidy diseases and autosomal aneuploidic diseases, right? Now, coming on to the next thing. What are autosomal aneuploidic diseases? Okay. So autosomal aneuploidic diseases. So they are known as sexual aneuploidy also. Okay, they could be known as sexual aneuploidy. Okay, so once we talk about sexual aneuploidy, you can have various stuff in sexual aneuploidy. Okay, so one can have various things. Just listen to this terminologically speaking because these questions can come in the school examination. Okay, very easy but may perplex you. Number one is known as monosomy. Okay, this is a general classification. Okay, which will refer to any autosomal or allosomal. But listen to this one carefully. Monosomy. Monosomy means once you have a diploidy minus 1, 2n minus 1 means in humans 46 minus 1, what you will get is 45 chromosome. So it refers to lack of one chromosome of the normal complement. Lack of one chromosome of the normal complement. That is the meaning of monosomy. Means every chromosome is a pair except for sex chromosome. X if it is a it's a pair, but XY that is a hemizygous state, very unique state. But the thing is, chromosome 1 is a pair coming from father. Chromosome number 1, this one coming from the mother. Maternal side, paternal side. So suppose this chromosome is deleted. So total chromosome became 45 instead of 46. One pair you have to take out. Okay. That means you have to reduce one pair to becoming a single chromosome. That will make it a monosomic stage, right? Now, if we talk about revision, I haven't started yet. This is the only place where I study biotech. Okay, Pratham, from next class onwards. Next class on Saturday. Okay, Arya Pratham, Arya is a new student. Next Saturday class of biotech we will take on Zoom. Okay, Arya and Pratham both will take on Zoom. I'll acquaint him with also biotech. So he is quite new and you want the revision also, and this will be done. So his syllabus I'm just completing this one. Today this errors in cell division chapter will be over. Okay, so semester's half yearly syllabus will be over. So my duty will be done from that part that I've covered is half yearly syllabus. And since you don't have any exam right now, so we will start the revision then. Okay, Pratham. So from next class, Saturday onward, we will do the biotech class on Zoom. Okay, so you can ask your questions. We will go for thorough revision. Okay, Arya also you can join in Zoom only. We will have a good interactive session. Okay, so that today I'll just finish up this chapter errors in cell division so that his semester's Half-yearly course is done. Okay. So monosomy, once you talk about, then we come to disomy. Disomy is known as 2n. Disomy is nothing but presence of two copies of chromosome, like what we have. So it's called diploid or disomy, presence of two copies of chromosomes. Samir just texted me that he is having some kind of, you can say, house shifting thing. So he will just watch this lecture, and then from next class onward we'll switch to Zoom. Okay. So that is your disomy. Then coming on to trisomy. Okay. Trisomy means 2n plus 1 means 46 plus 1, 47. Any, you can say, doublet or any complement, any homologous pair is getting tripled. Instead of a pair, one more chromosome is being added. So at any pair, 21st pair, 22nd pair, first pair, second pair, you can add one chromosome. It will become a trisomy. Total number will become 47. And suppose chromosome number 21 means every pair will have two chromosomes, father, mother. You add one more chromosome here. Okay. 21st now has three chromosomes. So total chromosome will be how much? 46 plus 1, 47. That is the meaning of trisomy. Means it is a condition where there is an extra one chromosome either in the autosomes or sex chromosomes. Or sex chromosomes. So that is known as the trisomy. Okay. Then we have tetrasomy also. That is 2n plus 2. So in case of tetrasomy, it is a condition where there are two extra chromosomes. Okay. So 46 plus 2, if suppose this happens, so 48. So it is a condition where two extra chromosomes are present. So these things are very, you can say, handy when you are writing any kind of examination. Okay. Then we have pentasomy. Means three extra chromosomes, 2n plus 3, so 46 plus 3, it will become 49 chromosomes. So it is a condition where three extra chromosomes are present. Three extra chromosomes are present. Okay. So now we'll talk about the abnormalities. Okay. So the first disease that comes in your course is the Klinefelter syndrome. Okay. Klinefelter syndrome, very important from school exam perspective. Directly they'll ask this disease, Klinefelter syndrome. Okay. So first two are very important. Then the next three may not be asked sometimes, but if the school examination is very difficult, that could be asked. So I'll just make you acquaint with the next three diseases also. Total there are five diseases that can come in biotechnology, but first two, Klinefelter and Turner syndrome, they are extremely important. Okay, so mark them as very, very important. So Klinefelter means this is an abnormality it is an abnormality or abnormal condition which occurs only in males. 1 mark question if it is asked in your school, you will write which occurs only in males. First point. Second point, the males have 47 chromosomes and what kind of disease it is? It is an allosomal aneuploidic disease or sex aneuploidy you can say, meaning that 46 chromosome means 44 first 44 chromosomes of 22 pairs are completely appropriate. What happens is the males will have an extra X chromosome. So the last pair, the allosomal pair will be a trisomy, 2n plus 1. So it will be an XXY. The male was XY, you have an extra X here. Again, due to non-disjunction theory. Okay, same theory applies here that I had taught you in the last class, because the non-disjunction primary and secondary, it could be happening that because in the Pachytene stage the crossing over happens, after that the synaptonemal complex needs to be dissolved. Okay, the dissolution of the synaptonemal complex happens in early and late diploidy. If that goes awry, that specific phenomenon, fundamental process goes haywire, doesn't happen properly, then what we have is we have one of the cell getting one extra pair. For that specific pair, one of the cell will get one chromosome only. So here it happens in the sex chromosomes. So 44 plus XXY. Total number of chromosomes 47. Okay. So these 3 points are very, very critical. Now characteristics. What all phenotypic characteristics you will find in such males. Okay. So the next point will be phenotypic characteristics. So enlargement of breast, number one, because one extra chromosome. Okay. Then underdeveloped testis in males. It is only in males. Okay. That's why I'm saying again and again underdeveloped testis. What does it mean? The males will be sterile. They cannot ejaculate. Sperm formation will be hampered. Okay. Then mental development will also be impaired. You can say mid-mental development, not complete, or retardation slash mental retardation. Okay. Then so what happens is if in very very rare conditions they are also not sterile. Okay, you will write this sterile, but I'm just telling you for your info that in some cases, okay, in very few cases, they are not sterile and can produce normal chromosomes also, normal sperm cells also. The sperms could be either 22X or 22Y. So they can produce normal sperms like anybody else produces, but that is a very, very rare case. That has been found, but in school examination you will write this one. Okay, don't write this. This is just for your information in rare cases. Okay, but this don't write this in your school examination. Then we come to the next disease, again very very important as per your course. Okay, Turner syndrome. Now it is an abnormality which happens only in females. Okay, again it is a female abnormality. Okay, females. Next, what you have here is This is again an allosomal aneuploidy or sexual or sex aneuploidy. Okay, allosomal aneuploidy. You have, this is a monosomic stage. Okay, means 2n minus 1. That means you have a chromosome number of 45 here. Okay, and since it is a monosomic disease and allosomal also, meaning that 44, the first 22 pairs are completely appropriate. In the next stage, you should be having this in a female, 44 plus 2, 46. But unfortunately, this X chromosome is not present. This is X naught, means 0. Again, disjunction, one will have 3 X chromosomes, other cell has only X remaining. So this is the problem here. Okay. So what you have is the one cell will have, you can say, after the meiosis which is happening in the female, one cell has got both the X and one cell doesn't have X. So the X coming from the father, okay, that is only the X remaining in the zygote. So then the development happens like this. So female has no X contributor there, okay, in the ovum. That is how it happens. The ovum doesn't have any chromosome related to sex chromosome. The ovum is, you can say, 22 chromosome. Sperm is 23, 22 plus X. So what you get is 45, where it is 44 plus X only. There is no such X because here X is missing due to non-disjunction in meiosis in that female body. Okay, one of the cells will have double X. If that meets, you will get a triple X syndrome. Okay, another way you are getting X naught in this unfortunate case. So again, you have only one pair, sorry, not even one pair, one X chromosome. There are no pairs of X chromosome, one X chromosome only. Okay, so now we'll look at the characteristics of this very disease. Now, the characteristic point of view is, means the phenotypic characteristics. So phenotypic characteristics. Okay, number one will be the webbed neck of a male, sorry, of a female. This happens only in females, webbed neck. Okay, then no breast development, flat chested. Secondary female characteristics will be nullified here. Okay, and then does not inhibit sexual maturation, means again sterile. Does not exhibit, sorry, sexual maturation, means they are sterile, just like Klinefelter. Most will be sterile. Okay, they're all sterile. In some cases, what happens in very rare cases, since it has only one X chromosome, so one will be 22 plus no chromosome at all. Okay, 22 plus 0, okay, means only 22. Another case, they can make 22 plus X, total 23, okay, in meiosis. So this will produce proper. So in again rare cases, they could be non-sterile also, which can produce a proper ovum in this fashion. Okay, but it is again a very rare case and exception. So write only sterile in your school examination. Okay. So then we'll shift our attention to three small diseases. Okay, which are not asked very lot. You can say which are not asked a lot, not asked frequently, but can be asked if the paper is very tough. So we'll do those diseases also. You can just make a note. Very simply, you can make a note. Mostly it won't be asked. Still, I'm giving it to you so that if the paper is tough, biotech papers are usually very tricky. So then you will be in a state to solve them. Okay. So next is known as Jacobs syndrome. Jacobs syndrome. In case of Jacobs syndrome, okay, happens only in males. Again, an allosomal or sex aneuploidy. What happens is you have an extra Y chromosome. So you have 44, you have 22 pairs are completely appropriate. All the allosomes are appropriate, but you have X double Y, double Y. Just the opposite of, you can say, Klinefelter. They have double XY, you have X double Y here. Okay, that is the problem. So you have 47 monos. You can say a trisomy again. Okay, 2n plus 1. Now, phenotypic characteristics. They are very violent. Mental development is completely, you can say, a lot retarded. So usually violent, criminal type. Okay, antisocial, very hot temper. Okay, then very high testosterone level due to double Y. And we know that if the testosterone level is too high, above the threshold level, one can become very aggressive. Okay, that is a psychological or psychiatric link of testosterone. Okay, it's an steroid hormone. Okay, produced from cholesterol. So mostly they are fertile. Okay, there is no sterility here. They are usually fertile. Very few times they're sterile, so they are usually fertile. Okay, and they can produce normal sperm. Okay, sometimes they can produce abnormal also, 22x, 22y normal. Okay, abnormal would be 22yy, 22xy. So these will be abnormal sperms, but normal also they can produce. They are usually fertile. Okay, so next we'll come on to the next disease, that is known as meta-female syndrome. So again, this occurs only in females. Okay, so they possess an extra X chromosome. Again, it's an allosomal aneuploidic disease. Now, what they have is an extra X chromosome. So 44, again 22 pairs are appropriate autosomes, but they have an extra X chromosome. Triple X means the result of, you can say, Turner syndrome, part 2, you can say, or the next cell, or the next ovum, because you had non-disjunction. So one ovum was left with only 22 chromosomes, one ovum would be left with, you can say, 24, because both the eggs came here. Now if it is mating with a sperm which has 22x, this will become what? This will become, you can say, 22 plus 24. Okay, so it is 22 plus 1, 23. This is, you can say, 23 plus 1, 24. So I can write it like this so that you can understand better. With 22 plus xx, total here is 24, here it is 23. So what you will get is 47. And how many x's are you having? 3x. So you will get this one, and this one is your Turner syndrome. So 22 x naught 45. So this ovum which was generated as a result of non-disjunction, which took both the X chromosomes with it or along with it in that specific cell, after meiosis will go for the generation of meta-female syndrome. Okay. Now the characteristics are, again it's a trisomy. Okay, 2n plus 1. Phenotypic characteristics. You have generally has a normal appearance. Okay, this is not that deadly. Okay, normal appearance. Why? Because there is something known as X chromosome inactivation. Okay, bar body formation. So that will be taught when I teach you genetics. So what happens is I'll just give you a specific explanation for that so that you can relate to it. Just imagine one thing. how many X chromosomes do we have, the males? We have one X and one Y. Okay. Females have two X chromosomes. And if mRNA is produced from both the X chromosomes, this one also means protein will be produced from this one also. This will bind to ribosome, will form protein in ER, rough ER. This will also produce protein. So won't the females have double the amount of proteins from the genes present in their X chromosomes compared to males? Okay, so wouldn't it cause, you can say, double the amount of protein at the genetic level or the protein level of X genes stay constant in a male and female, almost the same, stay the same in a male and female, in males and females both. One of the chromosomes is epigenetically silenced. Okay, the histones they wrap around it, I had explained to you, and those histones get heavily methylated and deacetylated, you can say. So one of the X chromosomes, you can say, become unaccessible or inaccessible to RNA polymerase, so no mRNA can be produced. This is known as bar body formation. Okay, how does this happen? We'll talk about that thing in the chapter genetics, which is also there in your course later on. Okay, so this is what happens in the female, so that they will only be using one of their X chromosomes for protein formation, just like the males. Okay, same thing will be happening. Very special stuff. So this is what happens in females. So triple X also what will happen? Two chromosomes, 3X, so two chromosomes will be inactivated. So no such problem happens. Okay, double bar body formation can take place in, you can say, in triple X chromosome. Sometimes, okay, the female can become sterile here. Very few, the females can become sterile. Okay, and if they are not sterile, they can again produce normal ovum, but abnormal will be this one again. Since they are double X, so one could be double X, one could be X. So again, this is the abnormal type, which will keep on producing either double XY, right, which is mate, that is your, you can say, Klinefelter, or triple X again if it mates with a X sperm, is with a Y sperm. So that will keep on going. So that is how the perpetuation happens. It keeps on happening from one to the other. Okay. So these are the diseases that we have. The last one is a very special disease known as the lethal disease, a lethal syndrome. Lethal means death, right? So why am I calling it a lethal syndrome? Okay, it happens only in males. Again, an allosomal or sex aneuploidy, allosomal aneuploidy. Okay, and then in this type, the male will lack an X chromosome. It's a monosomy 2n minus 1, that is 45 for, you can say, X chromosome or the sex chromosomes in male. So male is Y only, there is no X. So why not, you can say. It has to be XY, but the male has only one single Y chromosome. So you can write them as 44Y. There is no X. Okay. So since X chromosome is needed for very essential genes, Y chromosome doesn't have so essential genes. X chromosome has ACE inhibitor, sorry, ACE receptor, ACE2 receptor that you might have heard in case of SARS-CoV-2, that it attaches to the ACE2 receptor. So such, you can say, physiologically significant genes are present on X. So if the entire X chromosome is absent, you cannot survive. You will die. That is known as lethality. Okay. So that is how the person dies at a very, you can say, infant age. Okay, in case of X chromosome diseases. Okay. So after this, we will be coming on to the, you can say, the autosomal, you can say, aneuploidy. Okay. So I told you the ploidy refers to the number of basic chromosome set, and autosomal aneuploidy. Okay, that can happen. Okay. So I'll just give you a table if you see. So in euploidy, okay, sometimes what happens is Euploidy, I'll give you a table. Euploidy is a state. I'll give you the definition also so that it stays in your head. So the condition of an organism, okay, having complete set of chromosomes, or the definition is still incomplete here, or multiples of the basic set. Okay, multiples of the basic set. Now what does it mean? Means 2n is euploidy for humans, basic set is haploid n, multiple of the basic set means 3n, 4n, 5n, that will also come under euploidy. Okay, so this is not given in books clearly, that's what I'm giving you, so that if the euploidy is given in your syllabus but the proper definition in the book may not be given. Okay, so I'm equipping you with the tool to understand real euploidy. Okay, any, just make it haploid and then the integer, don't make it fraction, just apply simple mathematics, integer of any haploid. So you put any integer number, whole number in front of the n, you will get euploidy. So what I can say is, I can divide euploidy into two parts. One is a normal euploidy, which is known as monoploidy, that is haploid. Okay, that is n, and then polyploidy. Okay, you have diploid. Okay, which is the correct order in case of the humans. You have diploidy, monoploidy, diploidy, that is 2n, and then you have polyploidy. The polyploidy happens mostly in plants. You may have 3n, you have 4n, you have 5n, etc. 6n, 7n you can have. So this is all euploidy, monoploidy, diploidy or diploidy, and then polyploidy. This happens mostly in the case of plants. Okay, so that is what you should be knowing about euploidy. It's not only 2n, it's any integer of the haploid set, of the basic set. Okay, so euploidy is, you can say, lethal in animal, especially polyploidy of the euploidy version is lethal. If you have 3n chromosome means 46 plus again 23, so 46, 56, 66, then you will be having 69 chromosomes. So that is lethal in animals, but it is tolerated in plants easily. Okay, so that reason also I'll tell you when we start the genetics chapter. That will be very interesting. Okay, now what happens is, in case of, you can say, human beings, what we have is allosomal, sorry, autosomal, that we will be talking now, autosomal specific diseases. Number one is the Down syndrome. Okay, very important, is the most important, is asked in the question, is especially CBSE biology also, and then CBSE, or you can say biotechnology also. Down syndrome. Okay, very important. In NCRT, Patau syndrome and Edwards syndrome is not there in the biology syllabus, but in biotechnology syllabus, two more diseases I will be teaching, that is the Patau syndrome and Edwards syndrome, as per the biotechnology syllabus. Okay, but this is common for both biology and biotechnology in the CBSE course. Now, Down syndrome means, it is also known as Mongolism. Okay, many times it is also known as Mongolism, synonymic name, or Mongoloid idiocy. Mongoloid idiocy. Okay, what happens is, it is nothing but it's an autosomal aneuploidic disease, which means it is a trisomy again, that is 2n plus 1, but it will not be on the X chromosome, it will be on the autosome. So on the 21st autosomal pair, means the 21st chromosome will have three chromosomes. The 21st pair, it is supposed to have two, but there is a trisomy, okay, 2n plus 1 in the 21st pair of chromosome. That is your Down syndrome. Trisomy in the 21st pair of chromosome. And if you want to look at the karyotype of Down syndrome, I'll show you the karyotype also of Down syndrome. Karyotyping is a technique where you can analyze the structure and functional defects number of chromosome. Okay, so karyotype of Down syndrome. Just look at this image. Down syndrome. Okay, you can see here 21st. Yeah, this is a good image. Just look at this image. 21st chromosome has three chromosomes here. Okay, the 21st pair. Every other seed, 13 has two, 14 has two, 15 has two, 16 has two. But 21st chromosome has, or pair, has three. That is, it is a trisomy. It's not a pair. It's a trimer, you can say. Three chromosomes in 21st. Again, non-disjunction. One will have nothing. One will have three. Okay. So the thing is, one will have two first, one will have nothing, but one coming from the father will make it three, right? So when the ovum is being developed, or you can say sperm, anywhere it can happen. So there you will be having 22 chromosomes with no 21st. Here 23 chromosomes, sorry, 24 chromosomes with 21st doubling. Okay, this will be the case first. And suppose this is an ovum, or is sperm, it could be anything. So I'm taking it as an ovum. If it is mating with a sperm, which has 23 chromosomes, so it, on 21st also it will have one chromosome also only. So now 21st has become how many after fusion? Triploidy. And this one is having XX. Okay, no problem, XX. So, but it is lacking 21st altogether. So this will have monosomy on 21st chromosome. This will have trisomy on 21st chromosome. So this one will result into your Down syndrome. Okay, that is how you can deduce if you know meiosis pretty well. Okay, if you have read the chapter cell properly, you can directly deduce what will happen like this. Okay, going backwards, that is reverse genetics. Okay. That is your Down syndrome. This is the consequence, this is how it is produced, okay, molecular biology wise or genetics wise. Now, due to non-disjunction, it happens. Again, the same theory applies everywhere in case of aneuploidic diseases in humans. Now, it is the most familiar and common trisomy of man. Okay, and it was described by Langdon Down in 1866 in England for the very first time. The symptoms are as follows. The symptoms are asked in detail. Okay, so the symptoms pertaining to or symptoms of Down syndrome are as follows. Number one, short, broad hands, okay, with simian type palmar crease. Specialized creases are there. Then short stature. Then we will be having hyperflexibility of joints. Means the joints will be more prone to fracture and breakage both. Hyperflexibility of joints. Then mental retardation. Then broad head with round face. Then open mouth with large tongue. Open mouth with large tongue. These are the general characteristics of a specific person suffering from Down syndrome. Okay, mental retardation is one of the basic protruding tongue, cheek, all these things are there. Okay, one more thing that I'll tell you is I'll just tell you the molecular reason behind this. What you have is you have three chromosomes, right? On the 21st chronological order. So you are making mRNA from this one, and this one as well. Okay. So proteins are produced from all these. So extra proteins are being produced or not from the 21st chromosome genes. So only these and these alleles were supposed to be coded. Now these are also coded. Extra proteins are being produced. One of those proteins is also your interferon receptor. You might have heard of interferons. These are the immunological proteins produced by the virus infected cells. Interferon gamma, alpha, beta, all these are there. So when interferon receptors are being coded more, so the body will become hyper active immunologically also. So immunologically they will become, the body will become hyperactive. So the one more condition is the Down syndrome patients, they have a hyperactive immune system. Okay, because they make more interferon receptors, so more interferon, especially interferon gamma, can bind to it and cause more, you can say, secondary messenger event or signaling event. Okay, causing your immune system to become more hyperactive. Okay. Now coming on to our next two diseases known as Patau syndrome and Edwards syndrome. Okay, very very important. Patau syndrome and Edwards syndrome. Now in case of Patau syndrome, okay, Patau, Patau syndrome, what you have is again it's a trisomy 2n plus 1. It's an autosomal aneuploidy. What you have is chromosome number 13 has 3 here. 13 will have 3 chromosomes instead of 2. So you can write it as 47 plus 13. This is the way you can write. Plus means one more in the 13th chromosome. Down syndrome you will write like this, plus 21. One more in the 21st chromosome. Okay. So this is your Patau syndrome. You want to look at the, you can say, karyotype. You can just type here Patau syndrome. You can see. Just look. The 13th pair of chromosome has 3 chromosomes. Okay, it's not a pair again, it's a trimer, you can say. 3 chromosomes in the 13th chronological order. Rest are all double. Okay, so this is your Patau syndrome. And what happens in this disease is, in Patau syndrome, the cells have 3 copies of chromosome number 13, that we know. And a baby with, you can say, cleft palate is produced. Okay, cleft palate. Okay, so you can have crossed eyes, cleft palate. You can say very very, you can say, what to say, I shouldn't be using, but you look quite ugly. Okay, quite hideous if you are suffering from Patau syndrome, like technically speaking. Okay, so the thing is, you have crossed eyes. Okay, you have cleft plate, cleft palate. Okay, then cataracts in the eye. Okay, the eye lens, the protein becomes quite occluded. Okay, then what you can have is involuntary twitching of the eye. Twitching of the eye. So many manifestations you can have. You can have underdevelopment of optic nerve. It is the nerve that brings the signals or brings the signal from retina to the visual cortex. Optic nerve underdevelopment. Underdevelopment. Okay. So these things you may be having in case of, and then flat back of the head, then loops on fingertips, special skin rich patterns, okay, small and arched palate, big wrinkled tongue, dental anomalies, then congenital heart disease, so many things you can be having. Okay, when you come to or complex digit prints, the you can say the you can call it the fingerprints. Then achondroplasia. One thing is also there, achondroplasia. So if you don't know achondroplasia, or you can say achondroplasia. So what happens is you have short-limbed dwarfism. That is your achondroplasia here. That is known as short-limbed dwarfism. Okay. That is also seen in the patient suffering from Patau syndrome. ACH disease it is known as achondroplasia or ACH. Okay. So next disease, the last disease that we'll be talking about is the Edwards syndrome. Now, Edwards syndrome again, it's a trisomy. 2n+1. Next, 47 chromosomes. You can say plus 18. Okay, that is the chromosome number. On 18th chromosome becomes trisomy, means 18th chromosome will be like this. Okay, in case of Edwards syndrome, presence of an extra 18th chromosome. Okay, now what are the manifestations? Okay, increased risk of neonatal and infant mortality. You may die when you are an infant only, or just you are born. Increased risk of neonatal and infant mortality. Okay, so that could be one. Then psychomotor and cognitive disability you will be looking at. Okay, so psychomotor and cognitive disability. Much of achondroplasia is seen in Edwards syndrome compared to Patau syndrome. Okay, short-limbed dwarfism. So if one mark question comes, put achondroplasia here, because achondroplasia is seen in very few cases in case of, you can say, the Patau syndrome, but mostly it is seen in case of Edwards syndrome. Some symptoms they duplicate, like the congenital heart disease, complex digit patterns, okay, small mouth, okay. Mostly they die before 1 year of age, okay, that is your infant death, infant age death. So this will conclude your entire aneuploidic, you can say, events in case of the human beings, okay. So So any questions if you have regarding this chapter, you can ask me. Next class we'll be doing on, or we'll be carrying forward on Zoom app so that your interactive sessions can go underway, right? So cat and it was suffering from Down syndrome. Okay, okay, it may be, I don't know about that cat. So it can happen in cats also because they have chromosomes, 21st chromosome that can be having. So I hope you don't have any queries. And Arya, you can just text me after this class is over. Okay, so that I can see what's your syllabus is. Okay, then so we'll meet in the next class on Zoom regarding the biotechnology on Saturday, and we'll go for the revision. Okay, Arya, you can join in. I'll help you out in your course too. Okay, so let's meet you in the next class. Thank you.